With two slits, we found that laser light, or coherent light, that shines on a distant screen will give these peaks of brightness with darkness in between. We call those fringes. And these peaks would be equally spaced and equally bright based on the theory that we used. Okay, so this would be the case for two slits. And we were able to measure the distance. Let's say this was the central slit up to any of these other slits. This would be the first order bright fringe or maximum. This would be the second order. And we can measure the distance to any one of those by using the equation y sub m, so this would be 1, 2, equals m L lambda over d. Okay. And L was the distance to our screen from where the slits are. And D was the separation between the two slits, the distance between the two slits. Lambda is the wavelength of light that is impinging upon those two slits and therefore then diffracting through them and finally interfering at this screen. M is our order number, or the distance up from the central fringe. Okay, so that's what we learned from that. We were able to derive this from that introduction. So what's interesting is when you actually observe this, you don't see these equally intense spots. You actually see this. So for real, you see something that looks more like this. I'm going to draw that central peak, and then you have a dimmer one, and a dimmer one, and a micro dark, and then another one on that side, and here it's dimmer and dimmer, excuse me, and then maybe dark, and then another bright one, and dark. And that looks a lot different than that one. The middle peak looks pretty close to that one, but the rest of them look very different. And so the question is, well, what's going on here? Well, what we're going to introduce in the next video is something called single slit interference, which is not as straightforward as this based on the tools we already have with wave interference. But we're going to be able to derive that. Right now, I want to focus on what the difference is and how this actually tells us more information about our physical system. When we look at these slits, if I were to zoom in on them, I would see that I don't have really crazy narrow slits with a significant gap like I've drawn before. So it's kind of like I've drawn them like this, where we have a fairly big distance between the slits, and I've drawn these kind of teeny holes in these slits. But in real life, the slits are an appreciable fraction of the spacing between them. Okay, this might be, the spacing between the slits might be only 3 times as big as the slit width. So mechanically actually creating these slits themselves will have an appreciable width. And that width there is causing an additional interference, a very cool one. Again, not as intuitive, but it's a very cool physical phenomenon that's causing this non-uniform intensity across these peaks. Okay? And what we'll see is that the single slit effect causes an intensity envelope, okay, that looks like what we've seen for these, for the bright fringes and dark fringes and bright fringes and dark fringes, with 2 significant differences. One is the central peak is twice as big. Okay, so half of the central peak is as big as an entire side fringe, an entire side peak. Whereas with our pure double slit, even the double slit effect inside the single slit, the central peak is just as wide as any other. Okay. And so that's one significant difference. Again, the central peak is twice as wide for the single slit as any of its side maxima. Now, the other thing is that the intensity of the side maxima get less and less and less. Our simplistic theory here there's no reasoning in our theory to suggest the intensity of the double slit effect would get any smaller. It stays the same intensity all across. But the reason why we see this decreasing intensity on the double slit is actually not because of the double slit. It's because of the single slit effect that gets smaller and smaller and smaller. Now the way we can actually piece that out is we can shine light through just one slit. So I can block this slit right here and shine light, laser light through one slit and see just the single slit effect. So we don't have a double slit effect. So if this was my situation accomplishing this pattern here, and I block this one out, I would see just this envelope effect. I wouldn't see the other fringes within it. I just see this envelope effect. And so we say that the single slit creates an intensity envelope, meaning it creates an upper bound on the intensity, and then the double slit effect fills in up to that line. So it's not like you see this broad line here and then these on top of it. You only see this double slit effect, but it's been shortened by the available intensity caused by the single slit.